Welcome back to AP Statistics with Mr. Walton. Today we're going to talk about Chapter 8, Section 3, which we're going to use in terms of estimating a population mean by creating confidence interval. Bam! Yes, here we go. So the first thing is let's be reminded of our conditions. They are S. Remember we're looking for sentences. So let's put a little reminder up here. Use complete sentences. It'll help us out. But we're looking for an SRS slash random selection. Random allocation. All right. Then we've got our I. That's our independence clause. And we're going to use our 10% rule in context. All right then, now let's scroll down. Those are so very, very familiar. What about N for normality? This is where you'll hear me talk about the Fry rules. Okay, you're going to the Mickey D's and you walk in, you have three choices. You got large, medium, and small. And so that's our fries. If we have a large enough sample, that means that N is greater than or equal to 30. CLT applies. Woohoo! Rock and roll, move on. Okay? But what happens if, only have a medium-sized fry? That is when N is between 15 but less than 30, so between 15 and 30. This is where we need to remember graph and check the sample normality, which is in reality, we want to check its shape. Okay? And the key here is when we check the shape of our graph, if it's approximately symmetric, we're good. Okay? If there is only one outlier, we're also good. If it is slightly skewed, we're good. All right. So those are our helpful. Cool. We've got a medium-sized French fry size, so we're ready to rock and roll. But what if I have small fry, meaning I have a sample that's less than 15? This is, again, graph and check. But we need the sample to really be approximately symmetric, or we lose some validity here. So sample needs to be approximately symmetric. Okay. For further clarification, make sure to check your notes from class or to read the book because the book is fantastic. All right, so let's look at our first example. The amount of sugar in soft drinks is a concern. To test sugar content, a researcher randomly sampled 8 soft drinks from a company and measured the sugar content in grams per serving. The following data were produced. Use this data to construct and interpret. Bam! A 95% confidence interval for the mean amount of sugar in this company's soft drinks. All right. Try to write and list all the summary stats so that you can see them, and I'll jump in just in time and you'll see them pop up just in front of you. All right, so here are summary stats, and then we define the population as all regular soft drinks, and the parameter is the mean amount of sugar in a soft drink. And the reason we're saying regular soft drinks is hopefully you guys remember that diet soft drinks don't have sugar, they have the quote unquote fake sugar. All right. After we've set this up, then we need to look at our conditions. So try to set up your conditions, and mine will jump at you in just a minute. All right, and here we have our conditions. Please note that for normality, we have a small fry n is less than 15, so we will graph our sample data, and I made a box plot. Remember, you can always use that normal probability plot, a histogram, or the box plot. Since the graph is approximately symmetric, therefore, that means that this sampling distribution should also be approximately normal, and that means that all my conditions have been met, so I write my continuation statement here in pink, and we are ready to calculate the confidence interval and then interpret it. So, we have our confidence interval equal to 16.488 to 28.512, and our money statement, money with 95% confidence. I estimate the mean amount of sugar in a soft drink to be between 16.5 and 28.5 grams per serving. Bam! All right. Here we go. Moving on to example number 2. A researcher would like to estimate the mean amount of time it takes to solve a multiplication table. Multiplication problem, sorry. In the previous study, it was found that we have this information. How large a sample? Now, this is key. How large a sample? So we want to find n. So n equals blank. Now, what we need to remember is, are we able to use t critical in a situation like this, or do we need to know what this is all about in terms of the standard deviation from whatever we have? Oh my goodness, it's only about the sample. Hold on. Here's the deal. We can make a reasonable estimate using our z-critical. So we use z-critical in our margin of error, which is 1.96. So then we set up our MOE, and we use z-critical times the standard deviation of our sampling distribution. That's what we need to remember. Now, once we have this, we're going to do our serious math by plugging in. We have 0.5, 1.96, and then we know that this is 4 over the square root of n. Okay? Hopefully, you're going to use your nice math, and you're going to get n better be greater than or equal to 245.8624. Therefore, n is greater than or equal to 246 is what we're looking for. There we go. Ready to rock and roll. This is 8.3 brought to you by Mr. Walton.